In this video, I'm going to show you how to sketch a graph of a rational function, and we start by finding the domain of the function. We do so by looking at the denominator and excluding all the values which can make the denominator equal to 0. So domain of this function is all the values of x that are not equal to 1 or -4 or -1. The next step is to simplify the function and classify the discontinuities that it has at those 3 points. So here we can see that x plus 1 can be reduced, x minus 1 can also be reduced. So let's see what's left after we simplify everything. In the numerator we have x plus 1 cubed. In the denominator we have x minus 1 times x plus 4 squared. Notice how x plus 1 is not in the denominator anymore. So what we have at -1 is removable discontinuity. So it's not going to affect our graphing. It just means that at the end we'll have to remove that point from the graph, whatever graph we'll obtain. This also means that at 1 and -4 we have 2 vertical asymptotes. So we can graph those already. So this is vertical asymptote x equals 1. This is vertical asymptote x equals -4. So next step is to figure out the horizontal or slant asymptote. To figure that out, we have to consider the degree of the numerator and the degree of the denominator. So the degree of the numerator is 3, and the degree of the denominator is also 3. So when the 2 degrees are the same, it all comes down to just finding the ratio of the leading coefficients, and whatever that number is, that's going to be our horizontal asymptote. So let me write it cleaner here. So the horizontal asymptote is just the ratio of the leading coefficients, which is -1, because degree of the numerator is the same as the degree of the denominator. So we can also graph that line. So this horizontal line is our horizontal asymptote. Y equals -1. So the rest of the graph we'll figure out from the sign chart. So to construct the sign chart, we're going to take all the zeros from both the numerator and the denominator. So this is the 0 of the numerator. The zeros from the denominator I'm going to write with little circles to highlight that we have the asymptotes here. So if there is no circle, that means it's a 0 from the numerator. Now I'm going to label the ones with even multiplicity with exclamation mark. So now just by looking at the sign chart, I can basically ignore the original function and do the signs just by looking at the sign chart. But before we start, we have to figure out at least one sign on one interval, and we can use the horizontal asymptote for that. Since the graph of the function approaches to this line as x approaches to infinity and -infinity, that means that the sign of the rational function is negative to the right of 1 and to the left of -4. And all other signs can be determined from the notation on the sign chart. So if we didn't label 1 with exclamation mark, that means the sign changes. So from negative it becomes positive. There is no exclamation mark at -1, so again it changes, this time from positive to negative. And at -4 it doesn't change because there is exclamation mark, so it remains negative. Now, wherever we have asymptote, what does it mean to be negative on the right side? That means the function goes to negative infinity. Being positive on the left side means the function goes up to infinity. Now, at -1, there is no asymptote, so it goes from positive to negative, like this. And at -4, we have asymptote and both negative, so the graph looks like this. So if we copy this behavior on the graph, so we just copy it. At 1 we have positive infinity here, negative infinity here. Then the only thing we have to do is just to connect the lines, and that will be the sketch of the function. So connecting lines, it's pretty simple. Notice how it is okay to intersect the horizontal asymptote anywhere on the graph except as x gets large or small. So there's nothing wrong with this line crossing the y equals -1 line at this point. And the final graph is something like this. So this is the sketch of a rational function obtained by considering the sign chart. Of course, we can improve it by picking more points, but it seems like we were able to sketch it and highlight the most important parts. One last thing before we finish is we have to remember that at -1 we have removable discontinuity. So that means when we're done graphing, we come back to -1 and we make a hole here. So the function doesn't exist at -1. So now we're finished.